Okay, so I've mentioned that C++ is basically an offshoot of the C programming language. So C++ has all the stuff that C has in it. Earlier, you might have seen the newfangled way of looping through an array. And in this episode, we're going to show you the old-fangled C-style way of looping. And this is still totally relevant to what you're going to do in C++, since this is still valid C++, and you're going to see this pattern all over the place. And you're probably going to need to use it yourself quite a bit too. Okay, so this is a C-style loop. So many languages use this basic structure, including C++, C Sharp, Java, JavaScript, Go, many others. So once you've learned the intuition behind this syntax, you're going to be basically good to go in a number of other languages. So here's the anatomy. The for keyword just lets the compiler know that you're about to do a loop. It figures out which specific kind of loop it is by looking at the next part, the thing in parentheses. So inside the parentheses, we have three parts that control the loop. I'll go over these in details in a second. After the parentheses, there's a code block. If it's a single statement, you don't need to use the curly braces, but I recommend you do that anyway. Anything more than one statement, and you have to use the curly braces. The code block is going to execute possibly several times, depending on how you write the control logic for the loop. Okay, so that's the main high-level anatomy of a C-style loop. Now let's look at what goes inside that parenthetic expression there. So there's three parts to this, and each part is separated by a semicolon. The int I equals 0 part, that's the initializer. You could use a different variable here, j or foo or monkey or whatever you want. If you specify the type like we are here, you're declaring a new variable that only exists within this for loop, and it won't be usable afterwards. Typically, the variable you initialize here will be used to index into the array. So if you want to go from start to finish, you should just set it to 0. That's because the array's first element is at index 0, and the second element is at 1, and so on. The initializer is only executed one time at the very beginning. The variable you initialize here is commonly called the index variable. The next part is called the condition expression. This should be a Boolean expression, meaning it should evaluate to either true or false. If this part is true, then the code block is going to run. Otherwise, the code block doesn't run and the loop stops. Typically, you test if your index variable is still within range. And if you're looping from start to end, the thing to do is to test if it's less than the number of things in the array. In our example, we test if I is less than 4, and as long as that is true, we're going to enter the code block. The condition expression is executed potentially many times at the top of every loop to determine if that code block there is going to execute. The last part is called the post statement. Its reason to exist is to perform some cleanup at the end of each loop. You can think of the post statement as being a little piece of code that gets inserted into the bottom of the loop. Typically, it's used to increment your index variable. In our case, we're stepping through every element of our array from start to end, so we simply increment our index variable using the increment operator. The post statement is executed one time at the end of the code block. If the code block doesn't execute at all, meaning we didn't loop, then the post statement won't execute even once. Here's a simple statement that doesn't involve any arrays. We're just counting up from 0 to 1, but not including 20. First, we initialize a variable called sum, and we set it to 0. Then we run the for loop. The initializer runs only one time, where we make a new variable called I, and we set it to 0. Then the condition expression runs, tests if I is less than 20, and since 0 is less than 20, it says true, go ahead and loop. Then the code block executes, and I is 0, so we set sum to 0 plus 0, so that wasn't very interesting, and that's all for the code block. Just after the code block, it runs that post statement, which updates the value of I by incrementing it. So I is now going to be 1. Think about for a second what you think it's going to do next. So how about the initializer? No, that only runs once. How about the condition expression? Yep, that's it. Okay, so run the condition. Is I less than 20? Well, I is 1, which is obviously less than 20, so let's loop again. Enter the code block. Add sum's current value of 0 with i's current value of 1, and put the result back into sum. So now sum is 1. Run the post statement, which increments I to 2, and do it again. So this continues for a while until the time when I is 19, and the code block finishes and sum happens to be 190, and the post statement runs and increments I to 20. The condition expression then tests if 20 is less than 20, which it isn't, so the code block doesn't run and the loop is complete. So the next statement after that is that C outline. So it prints out the sum of 0 to 19 is 190. This example uses the index variable to index into a little array with 4 values in it. The loop works exactly the same as it did with the previous example. The only differences are that I will only go from 0 to 3 inclusive, and that now we're adding each value of the numbers array by using numbers sub I. This pattern is extremely common. You initialize an index variable named I or maybe j to 0, and then you test if I is less than the length of the array and increment I after every time the code block runs. Inside the code block, use I to index into the array to get the value you're after. You'll see this all over the place, and I do understand that this is like a super confusing thing to see for the first time or maybe the 9th time, but eventually this is going to make sense and it soon will become second nature to you. Anyway, when this code runs, it prints out the sum of numbers, which is 22. And that's it for C-style loops.